Let me draw your attention to something I found in this Lexicon MPX series MIDI implementation guide. I have one of these MPX100s, and so I thought about building a system exclusive editor for it because I didn't find one online. And then I found this tasty morsel. In some cases, these parameters are not otherwise available from the front panel of the unit. That's right, there may be sounds in my MPX100 that I've never heard before because I've only accessed the front panel and haven't been using System Exclusive to edit it. So here we go. Off to build a controller System Exclusive editor for the MPX100. Now I need to know what kind of messages I'm going to send, what kind of parameters. This describes some basics that are sort of common for every message. You always start with F0, you always have a manufacturer and a product identifier. It looks like some things that specify the mode of the message. And reading through here, query messages request something from the machine. And data messages set a parameter value. So I'm interested, at least at first, in setting values. So I'll use data messages. Looks like the fourth part of every message is going to be 0 if it's a data message, and the fifth part is going to be 0, 1 if it's a data message. So let me come down here and examine one of these example or sample messages. Again, I'm not interested in query right now. I'm interested in sample data message that would set a parameter. So all of these parts are basically the same for any sample data message, it looks like. And then I think the sixth part is the size of the parameter data, and in this case it's 2 bytes, and when you send it, it gets nibblized. This happens a lot in System Exclusive. Basically, when you send another high value, basically another byte with a 1 at the highest position, at the most significant bit position, it's usually to signify the end of the System Exclusive message. So different manufacturers do different things to basically ensure that that first bit is going to be 0. In this case, they nibblize, which means these 4 MIDI bytes represent 2 data bytes, with each 4 bits being split into a separate byte and paired with just 0 to make sure that that top bit stays 0. So you'll see nothing is, all of these top nibbles are 0 between the start and the finish of the System Exclusive message. Furthermore, they explain up here, the way they nibblize is that they take 2 bytes and they take the lowest 4 bits, the lowest nibble of those 2 bytes, and then the next, and then the next, and then the next, so that this is actually 0, 9, E2. You can see that explained here. Now, I say explained. Now, they sort of touched on nibblize this and that, and then you can work out from looking at this and looking at what the value is supposed to be, that it was nibblized and sent to lowest nibble first. And they do lots of things in this manual with pairs of bytes, which I call a hextet. So if you look at this table of parameter addresses, they're sending a pair, a pair, a pair. Again, each pair, each hextet of bits is going to be sent lowest nibble first, then next, then next, then next, all paired with a 0 for a high nibble. So this is each hexadecimal digit represents 4 bits. So this will be sent 02, 00, 00, 00, just to send that. Now it doubles the bandwidth, but keeps that top bit 0. So do your thing, Lexicon. So let's look at that example message again, just to make sure I know what I'm doing here. So it explains, this is sort of nicely laid out. It explains that number 6, the sixth part here, is the size of the data. And I can see, because this is sent as 4, it is 2 bytes. So that makes sense. 7 is sort of always 0, 0, 0, 0. So I guess internally they're looking at those hextets. And so this is basically altogether the number 2 or the number 1. And they had a weird way of talking about it in the manual. But that's okay, do your thing, Lexicon. And so part 8 is, again, the value. And part 9 is the address of the parameter. So parameter identifier. And it took a little figuring and rereading this to figure out what was going on. So for instance, they're saying that this is RT delay 1. And if I go find RT delay 1, now I know it has to have a 4, a 4, a 5, and a 1. If I go find RT delay 1, which one was it? There it is. So it's this RT delay 1 with a 4 and a 4 and a 5 and a 1. They explained that the first hextet of the parameter address, or the parameter identifier they call it, is the number of hextets in the parameter identifier. So when you see a 4, you know that you send this and this and this and this. And what's really confusing about this table is that they printed all of the zeros. I think I would have left that blank. I think I would have left this off. This is the last column of this table is just the maximum. It's 2760 in hex. Just in case, in case you're this far into a MIDI implementation chart and you don't understand hex, I guess that would be useful. I don't know. But this doesn't even get sent. So, and I found that very confusing. But I've now figured that out for you. So there you go. Thanks for watching. Let's go to, I wanted to talk about the way that these parameters are organized. So there's something called algorithm that this says runs from 0 to 9, which I haven't figured out if that's quite right yet. But that is just knowing some semantics about how effects work, how audio effects work. Plate would be an algorithm. So I figured out that this section goes with 0, this section chamber goes with 1, and so on. And then they have a few at the end that they're not just one algorithm, but they're multiple algorithms together, which is probably groundbreaking in 1990 or whenever this box came out. So I realized that each algorithm has a different set of parameters, and so I want to collect those together, and I want to show these parameters for editing when the plate algorithm is selected. And I like to do that in Ctrlr by adding a tab controller or tab component, and then putting in tabs for each of those sort of sections, collections of controls that go together. So that's how I'll start in Ctrlr, and with the tabs selected, I think it starts with no tabs. Let me add one. Okay, I've added one, and it said that that algorithm could be 0 through 9. So that sort of seems like there are 10 algorithms or 10 groupings of controls that I would want to see together. So I'll add 9 more tabs. And there are my numbers 0 through 9 for each algorithm. Now, to change the algorithm, I have to reference that system group of parameter addresses. So I'm going to be sending I'm going to be sending the normal system exclusive sort of header that gets sent for each data message to this box, which is going to look like that. And then I need to send, I think I need to send a 1 for the size of the parameter, because audio parameters are 2 bytes, and this algorithm is actually not. It's a system parameter, and system mode parameters are 1 byte, except global tempo, which is not algorithm. And to send algorithm, I'll need to send a 1. So this is going to be a 1. This is always 0, 0, 0, as is explained here. It's just always that. And then I'll send my 1. Again, one byte of value is going to take 2 MIDI bytes, because it'll be nibbleized. The least significant nibble will come paired with 0, and then the big nibble paired with 0. And then I'm going to send that. Parameter identifier, which is listed in the table down here. But I have to be a little careful how I look at it, because, as I know, the first column is the size of the parameter identifier in hexstats. So I'm going to send that, and then that, and then that, and I'll be done. I won't send these zeros, just like you wouldn't send any of these, and they shouldn't be in this table. But enough of that. So what I like in Ctrlr is that I can send some system exclusive MIDI data when this tab controller switches. I wish that I could just have a system exclusive formula in the component, and I don't think it's available, because I think this is called a passive component. If I go add another one, where are they? Groups and views. Anyway, groups and views are passive components, and so they don't have their own ability to just define a system exclusive formula here and send it. So what I'll have to do is I'll have to run a little script to send out my system exclusive parameter change command to go along with the tab. So here is where under the component menu in this properties panel is a space for a Lua function that's called when the current tab changes, and that's when I want to do it. So if I hit this tab, I want to send, hey, MPX100, please switch to algorithm 0, is what that means. So I think this button will allow me to start coding the Lua script that will be able to send that MIDI data. And I'll call it modulator changed. Nice general name in case I want to reuse it for something. And then, wait a minute, and now I have to select it. Modulator changed. Now I can edit it there. Okay, and they give me, Ctrlr will give you a stub function that's ready to fill in with whatever logic you want to run when that tab changes. Device code is those first few bytes that are sent with every system exclusive message to the lexicon. And I think 01 indicates that this is a data message, but since this is always the same, I just made a variable for that, and I'll keep sending that. Then modulator changed, the handler function will get a couple of arguments, the modulator that changed and the value that it changed to. In this case, the value indicates which tab has been clicked, and we're going to get the number of bytes in the value argument from that modulator custom index group that I was just talking about, which is the hack that uses custom modulator index group as a just an unused field where you can put something. So in the case of the algorithm, it's 1, and in the case of setting the algorithm, the identifier for the system exclusive parameter is 2 more hextets long, and the whole thing is that. So that will go here. I don't need that initial 0. So this function will read that property from the modulator, and it comes out as a string, so I cast it to a number. Actually, I don't know if it comes out as a string, but I cast it to a number. And I take the value, which is, again is the tab index, which is 0 through 9 here, and I'm going to write a function in the future called nibblize, which spits out those first 4 bits, the least significant 4 bits first with a 0, and then the most significant 4 bits with a 0. And number of bytes indicates how many bytes I want to send. So then I want to get the modulator custom index, because that is how I'm storing the parameter address. And I want to cast it to string because I found that I had goofy problems if I didn't. And then I'm going to write a function called process parameter address that takes that string and returns all of the nibblized MIDI system exclusive bytes that I need to send that value. Store that in this variable. And then I create my message by starting with a device code. Now table concatenate, it just puts these things together with spaces between them. Start with the device code, then use the nibblized number of bytes, which will produce that 02 and then 3 00s, because it takes 4 bytes to send to, and nibblized means that the least significant comes first. So if I want a value like 02 and then 3 00s, this is how to do it. Parameter value is my nibblized value, which is my tab index, and then parameter address is my prepared all of my MIDI bytes that represent this custom modulator index number. And then F7 is how you generally end these system exclusive messages. Now in the manual, in the implementation charts, the examples use E7, and I tried that, and what actually happened was that my MIDI monitor said F7 anyway, because I think controller knows you're supposed to end these with F7, but it didn't work. So I don't understand what was going on there, but I typed F7 and it worked. So then I used this function to send the MIDI message, and it has to be formatted in this kind of a class. So it's just a string here. It's bytes separated by spaces, hex bytes separated by spaces. I format it into this kind of a message object, and then I can send that with a function on the panel. So I still need my nibblize that I promised I would write, and it's here, and I'll tell you what it does. So it accepts the data that you want to nibblize and how many bytes you should nibblize, and you're going to get double that many nibbles, because nibbles are 4 bits and bytes are 8. I use this big integer class, and I cast the data to that basically, so that I can use this get bit range, and that helps me loop over the number of nibbles that I want and get 4 starting at 0, and then the next time starting at 4, and the next time starting at 8, etc., getting 4 bits each time. So I start at the small end, take 4 bits each time, and each time I take them, I format a byte with 2 hex characters, and that basically appends the 0 character onto it. So like here, where I'm going to send 5, I actually send 0, 5. Here I'm going to send 4 for a nibble, I send 0, 4. All those are inserted into the table called bytes, and then when I am done doing that, done looping through the nibbles, I put those byte strings, formatted strings, all together with a space between each one. And that gives me what I need nibbleized. So the next thing I promised to write was called process param address, and that takes this big sort of ugly string that I've hacked into this extra unused parameter and loaded here, and it creates a list of nibbles, and starting with the least significant one. So first I create a table of hexstats because I'm going to parse this out, and basically I split the string by white space and I put all of the resulting parts into that hexstat table. And then I'm going to create something called param address. I needed to type local because I used that variable somewhere else. And for each index and value in that hexstats table that I had created, these are all strings of 4 characters, 4 hex characters, I nibbleize them, and then I insert the result of that into my parameter address table. And when I'm done nibbleizing those hexstats, I return the results of that, which is a string of hex characters, pairs of hex characters, separated by spaces. And that is the code needed to send the message, send the appropriately formatted and nibbleized message when my modulator changes. Every time you change code in Lua or in Ctrlr, you save and compile so that the latest version runs. And if I now change tabs, so it's definitely changing algorithms as I change tabs. Good. So I'm going to go ahead and name the tabs, at least the visible name, with the name of the algorithm, so that this component makes sense. So I'll go through the algorithms and find out, just by going through the order that they appear in this implementation table. So it looks like it starts with plate and then chamber. Then inverse and so I made a weird comment that I wasn't sure if 0 through 9 was right, because in the table DX5 is the last thing listed. But if we really had 0 through 9 for algorithm settings, this last tab would not make any sense. So I'm just going to keep going and see if I can make something happen with that, or if maybe it was a misprint. And now that I've got these named, I think that's a believable plate. Chambers need some settings to sound like anything. Ambient seems realistic. These may have some multiple things going on, and I don't know what that mystery 9 is. So I'll keep going in part 2. I hope that you watch the next video and watch as I start to set down knobs and implement the individual parameters of each of these algorithms.